Welcome everybody. Today I'll have a conversation with Professor Sarah Seeger, who is a professor of planetary science and physics at Massachusetts Institute of Technology. Thank you very much, Professor Seeger, for giving me your time. So you were born in Canada, and how was growing up at that time? Were you always interested in natural science during your childhood?
I think most children are curious about the world around them. I don't know if I was any more or less curious than other people, but I do remember always trying to find an explanation for anything around me. I remember the moon, particularly. It's so big in our sky. And I hope that children everywhere, can see the moon and wonder about it.
But did you decide at that time that one day you want to study more like advanced topics in physics or in mathematics?
No. When I was a child, I was not thinking about being a scientist. I don't even know if I knew what a scientist was, actually. And right through being a teenager, I didn't think about it much. My dad was a doctor, and he expected me to be a doctor as well. So although education was a focus in my family, it wasn't on science per se.
So who was your role model at that time?
Well, I didn't have a role model per se, but I was involved in helping start a youth science group for high school students. And one of my friends in that group was really interesting. He was pushing me to become a scientist. And he would compare, he would say something funny like, do you want to be like Einstein, or do you want to be like Dr. So-and-so, like a kind of boring doctor who we both knew. So I think having my peers understand the value of science and the ability to explore and ask and answer brand new questions, I think, believe it or not, that played a formational role in my thinking.
And when did you decide to do PhD at Harvard? Did you choose your PhD topic at that time, or you were taking courses?
No. At some point, I realized I could be an astronomer for a job. And I just want to share this story for a moment, because that was when I was a teenager. I lived in the city of Toronto, and I was walking to my high school where I cut through the University of Toronto campus. And I saw a sign for an open house, a university-wide open house. And this was for the astronomy department in particular. So I went to the astronomy department, and wow, I learned you could be an astronomer for a job. And I had a budding interest in astronomy. So I rushed home to tell my dad. He's not alive now, but I lived with him on weekends. And he got angry. He told me I had to find a job and support myself and not rely on any man. And he didn't think an astronomer could get a job. So that's why he wanted to make sure. And as a parent, regardless of the gender of your child, you want them to be able to get a job and support themselves. Otherwise, guess who's supporting them? Maybe the parent, right? So I went through school not knowing if I could be a scientist, but one day I decided I was just going to do it because I loved astronomy so much, and I'd had a summer job while in university at an observatory. So how I got to Harvard was I applied to a variety of schools for graduate school, and Harvard admitted me to go there. So I went to Harvard, not knowing what I was going to focus on for my PhD, other than it was going to be a topic in astronomy.
So how did you convince your father at that time that, okay, you can make a career in astronomy?
It's a hard one, actually, yeah. And a lot of young people ask me about this when I tell that story, because we all have a cultural obligation, not just to our culture, but to our family and the people who raised us. It's a very tricky one, actually. I mean, he had also raised me to be independent. And as soon as I realized that in America, in North America, if you're admitted to graduate school in science, it also comes with a stipend. So your tuition is covered and they pay you enough to live on. It's not a huge amount of money. You can't go on vacation really somewhere exotic. But actually, if you have a roommate or if you're married, it's a little easier to get by. And as soon as I realized I could support myself, even at a low pay, I just decided to do it anyway. And I don't remember if he was happy or unhappy. I do remember he was always, even while I was in grad school, trying to convince me to go back to medical school.
That's interesting. Yeah, because I'm particularly asking this question because in India, sometimes that women, they need to convince their parents. I guess, in my opinion, in rural areas, particularly, they need to struggle more to convince that, okay,
I understand. Yeah. I When I was growing up in India, when I was growing up in Toronto, I actually had a very good friend, one of my best friends. A young woman was from India, and her parents were very strict. Even when we were in university, so she would have been, let's say, age 20 or 21, it was really hard for her to convince her parents to sleep over at my place. And I was staying in an apartment at the time. You know what I'm saying? It's like I understand how strict the culture was. Like she wasn't even as an adult allowed to like just say, okay, mom and dad, see you later. I'm going to sleep over at Sarah's house tonight. Like it just wasn't, she was able to eventually. And when nothing went wrong, I think the parents were good with that. And we went out of town once together. So, but I understood how much effort it took over a long time just for that. So I understand the whole career. It's very challenging actually. And it takes, you have to be sure you can support yourself financially, because part of it is, if you can support yourself, at least that's a good thing. And I know in a lot of families, parents aren't making a lot of money anyway. It's hard to do actually. Do you follow your passion and dream, or do you satisfy your family's goals for you? It's always been an age-old problem for men and women, but I can see how it's especially tough for women.
Yes, absolutely. So yeah, I'll come back to this topic again. So let me talk about your research during your PhD. So what was your research topic?
Well, I started out working on cosmology.
Yeah,
on a problem in a problem in the early universe. And it was an assigned problem by my advisor, specifically about when the protons and electrons that are just floating around in this hot plasma, when they combine to form atoms. It's like a game of, do you know this game called musical chairs?
Yeah.
It's like a child's game when, everyone rushes around, the music stops, and you have to find a chair. I always think of that because the universe is expanding and cooling. And not every electron can find a proton. Some of those electrons and protons, they don't bang into each other and become an atom until it's too late. And so some of those electrons, they're actually still floating around somewhere, and protons. But why it's important is because the last scattering surface, like the electrons, photons are scattering off the electrons continuously. But at some point, the electrons become too diffuse and the photons don't scatter off them. And recorded in that last scattering is the density and anisotropy of our universe at that time, which imprints essentially the seeds of everything that came to be. And so the cosmic microwave background radiation, the temperature anisotropies on the sky at different angles, they require understanding that in a lot of detail. And so my work was the first modern computer code trying to model how that happened and when and how long that last scattering surface lasted as compared to a simplified version of the hydrogen atom. And I actually discovered a little difference, which was good. That's where I started. But once I finished that project, it was time to move on to a PhD thesis topic. And there's a phrase, timing is everything. And at that time, the first reports of exoplanets orbiting sun-like stars came out, 51 Peg-B, the first planets orbiting sun-like stars. And my thesis advisor offered that to me. He said, why don't you consider working on these new exoplanets?
I have read those two papers. You have written two seminal papers actually on recombination that took place in the early universe. And of course, the latter code, we have now recombination code, which are much faster, high-rake and rake fast. But, and people are actually putting constant on the width of the last scattering surface and how it happened. But why you did not work on those topics? Because both of those papers have, if I remember correctly, more than 500 or close to 500 citations. And did not you feel to work on those topics at the latter time?
Well, I did want to keep working on it. I have one more paper in the series, and what I was supposed to work on were the spectral features in the background radiation, because there are a lot of, it's a zero-sum game with the electrons, but imagine an electron is excited to a certain level. It can cascade back down. We can be re-excited. The photon can be absorbed by another atom, helium versus hydrogen. So there's some, lines, but I never got around to that because my advisor, Professor Dimitar Sasolov, and another professor on my committee, Professor Bob Noyes, they sensed that although exoplanets were brand new and the community was incredibly skeptical about it, they sensed that it could be something big. I don't know how big they were thinking, but in contrast to the work on the early universe, that particular problem I solved. making a model of the hydrogen atom, making a computer code, that did not have nearly the potential of a brand new field. And I think that, I don't know for sure, but being an advisor myself, I think they would have understood that if exoplanets went nowhere, I could have gone back and picked up working on recombination in the early universe again. So I think it was really strategy, because at one point I actually got a job as a postdoc and I was ready to finish my thesis. And I was just, you know what, I've kind of already written a thesis in recombination in the early universe. I asked my advisors, can I just like spend a bit more time on that and call that my thesis? And they said no, because if you do that, you won't be motivated to get the exoplanet work done. So it was a matter of strategy, actually. And I would be grateful to my university and to my advisor for taking that hard line.
Yeah, the irony is people are now actually thinking about the same problem now, like detecting the recombination spectra with some Shapley spectral distortion experiment that they are proposing to. So yeah, I am just connecting the dots, and it's
okay. I should have worked on it. I should have done. But you know, at the time, the dust really gets in the way, right? There's like background dusts in our galaxy, and it just didn't, like, at the time. I mean, of course, everything gets better as decades go by. People are more clever. But in the back of my mind, it did feel like there was always some kind of fundamental limit to seeing those lines. And yes, my postdoc advisor wanted me to do that. He was really big on it. He had a good nose for fundamental problems and a good feeling for what needs to be done. So I tried to live without regret, let's just say.
So how did your postdoc life at Princeton, IAS, Institute of Advanced Studies, and did you continue to work on exoplanets there?
I did. I went there to work on exoplanets. I did get one other paper on recombination in the early universe, because believe it or not, it's going to sound like ancient dinosaur times, but back then, the peaks of the cosmic microwave background, the temperature anisotropies at different angles on the sky, they weren't detected yet. The first one was, more or less. The second one, it wasn't clear if there was a second peak. So I got to work with the famed Jim Peebles on a paper we called delayed recombination. People were trying to figure out, if there's no second peak, how is that possible? So for what it's worth, I did do a little bit more work on recombination, but I did go there and I worked on exoplanets. And it was interesting because not a lot of people were working on that field at the time. There was a lot of skepticism, lingering skepticism as to whether the signals people were finding were exoplanets or not. But it was mostly a skepticism that the field would go anywhere. Because at that time, and mostly still today, we're finding exoplanets in the combined light of the planet-star system. So we have the radial velocity method, where we look for the stellar wobble as the planet and star orbit the common center of mass. We have transits, where we monitor the brightness of the star, which drops by a tiny amount if a planet fortuitously orbits, as so it goes in front of the star as seen from our viewpoint. And so that's all great, but there's a lot of decimal places involved in making a relative measurement. And people didn't think the field could go to smaller planets to actually observe atmospheres. I think there was like a big skepticism about the field in general. So amidst all of that, I was just working away, but at the Institute for Advanced Study, there wasn't so much limited thinking. People were more open-minded and wanted to see new work.
We just go back to some basic questions for the audience. So though we talked about exoplanets, so what are the exoplanets and why these objects are interesting to us?
Great question. Well, just to put everyone on the same page, I always like to start with the background night sky. I know it's hard to see the sky from most cities, but you know, you can always see at least one star, right? Not our sun. Our sun is a star, but I feel like even in the city, there's maybe 5 or 10 stars that show up. So all those stars are suns, and people thought for thousands of years that surely if our sun, a star, has planets, those other stars must have planets also, and they do. And we've always wanted to know about this. People love the idea of so-called exoplanets, planets orbiting stars other than the sun. There's all the movie series like Star Trek and Star Wars. And so in some sense, that desire to know what is out there, what is beyond Earth, it's always been with us. And so what's amazing about exoplanets today is the sheer diversity of them. We expected to find solar system copies Yet we can arguably say our solar system is not only very hard to find, but it also appears to be quite rare. So we found planetary systems having a Jupiter where an Earth should be, or a Jupiter, we call it a hot Jupiter, 10 times closer to its star than Mercury is to our sun. There's planets 2 to 3 times the size of Earth, which appear to be the most common type of planet in our galaxy, but we have no solar system counterpart. We don't know what these so-called mini Neptunes are made of or how they formed. So we have so many questions now. So it's interesting for all those reasons that people have always wondered. We dream about planets elsewhere via science fiction. And now that we found them, we're very puzzled as to what we're finding and why it exists. And finally, we want to know, is there life out there? And these planets, some of them are the right distance from the star to host life, and we hope someday to find signs of life.
Yeah, so when I was a child, one day I read the newspaper and I got to know that Pluto is not a planet anymore. So why is that? Why Pluto?
That's a tough call. That's a tough one. There's 2 reasons. One is kind of scientific and one is political. Pluto got voted out of being a planet. And it's a terrible thing to say that science can be done by voting, because it shouldn't be. But you know what the argument boiled down to? There were two separate arguments. One is that a planet should be anything massive enough so that its gravity draws itself into a sphere. But if we'd like to choose that definition of a planet, we'd have so many planets, because Ceres, one of our asteroids, is actually a sphere. There are a number of different Plutos. The list would keep growing. The second idea is that a planet is something that is massive enough so it clears out everything else in its orbit. So Earth is the only thing in its orbit. Okay, if something else comes into Earth's orbit, Earth's gravity will knock it away. It turns out that Pluto didn't clear its orbit. You can call Pluto king of the Kuiper belt. It's like an asteroid belt, but it's icy bodies out at Pluto. And so as the Kuiper belt was discovered and thousands of objects or more, people were uncomfortable with Pluto being a planet because it's not massive enough to clear its orbit. So essentially it was a vote between those 2 categories, and the vote for a planet must be able to clear its orbit won out, and hence Pluto was demoted. I bet as a child you didn't get all of that, you just got that. Yeah. Well, as a scientist yourself right now, which one would you vote for today, leaving emotion out of it?
I think I'll rather prefer to have a list of planets, including Pluto as a planet.
All right, well, there you go.
Yeah. And according to you, what is Planet 9? Because people are writing paper that if Planet 9 can be a black hole or something. What do you think about it?
Well, I think I'll hold out for a little longer. It's interesting, but as you know, astronomers have been searching for Planet 9 in archived data and with new observations. And unfortunately, Planet 9, it's getting extreme. It has to be very far away and very dark. So I think if we wait a few more years and can rule out the existence of Planet 9, or strongly rule out the existence of Planet 9, then I'd be willing to entertain these other ideas.
You are currently working on the atmosphere of Venus, and there was a paper on the potential discovery of phosphine in the atmosphere of Venus. So could you please walk us through that paper and tell us what is its importance for the community?
Yes, well, let's start back billions of years ago here on our Earth, where simple single-celled bacteria called cyanobacteria figured out something very clever: how to harness energy from our environment, from the sun, photosynthesis. And in the process, cyanobacteria, they generated oxygen as a waste product. And today, our atmosphere is filled to 20% by volume with oxygen. It shouldn't be there because it's so reactive. Oxygen should react away. It has to be continually produced, and we don't really have anything else that can produce oxygen in such large amounts. So believe it or not, for nearly 100 years, astronomers have thought of oxygen as a sign of life on another world if we could search for it. And the first astronomer that proposed this wasn't knowing about exoplanets, of course, but was probably thinking about other planets in our solar system. Now we have a list of a lot of gases, including phosphine, that are what we call good potential biosignature gases, possible signs of life. On Earth, phosphine is only associated with life. We have very little hydrogen. Phosphine, by the way, is a phosphorus atom and 3 hydrogen atoms. So it's only associated with life because we have very little hydrogen and it takes energy to make phosphine. So let's fast forward to present day when an astronomer named Professor Jane Greaves wanted to search for signs of life on Venus. And she worked through all the possible gases. She worked through some literature and she came across some papers about phosphine on Earth as being only associated with life. Either we make it as pesticides or it's associated with life in oxygen-free environments. And phosphine has a rotational transition. Molecules rotate at certain frequencies, and it has a rotational transition at radio frequencies where Professor Jane Greaves is a radio astronomer. And I was working on phosphine, my team was, as a potential biosignature in the atmospheres of exoplanets, working on this theoretically, because our observations aren't there yet. So someone connected our two teams. And in September 2020, our team made an announcement of the discovery of phosphine gas on Venus. Now, part of the work we did was not just the radio astronomy and analysis, but asking what on Venus could make phosphine. And we went through a long list: volcanoes, lightning, meteorites delivering phosphorus, minerals upswept from the surface. And nothing we worked on could produce phosphine in any significant quantity, even to match the reported value of about a few parts per billion, which is tiny, but even all those things couldn't seem to make it. So we don't claim we found life on Venus. We just said we found a gas that doesn't belong. That's sort of in this history of thinking about how to find life on Earth. It kind of matches that, and we leave room for the possibility of life. Now, what's really interesting is Venus, we all know it's too hot for life of any kind at the surface. But just like on Earth, if you hike up above the surface, it gets colder and colder. So too on Venus. Once you're 50 kilometers above the surface, higher than any mountain on Earth, but once 50 kilometers above, it's actually the right temperature for life. So the concept is perhaps there are little microbes floating around inside cloud particles in the atmosphere that are generating gases of one kind or another. Now, before we get any further on this, I just to sort of in the interest of full disclosure, it's a very controversial discovery. Independent teams have analyzed the data. Some have not found a signal in the data. Some have found a signal, but want to attribute it to another gas other than phosphine. So it's still kind of unfolding right now, but that's the phosphine story.
I just want to know that how to confirm these results, because are there any ways that we can use a different instrument or send a space-based telescope to confirm these results or similar results?
It's hard to confirm phosphine. The radio, as you know, can penetrate clouds, it can penetrate dust, but the Venus clouds are so bright, it's what makes it very bright in the night sky. And so most of our observations, if we wanted to look at near infrared wavelengths, for example, they're not getting into the clouds. That's reflected life off the top of the clouds. And we think we've measured phosphine in the cloud layers. So people are still trying. We had some observations on the infrared telescope facility in Hawaii. Some people are using SOFIA, an airborne observatory, an airplane that can fly, above a lot of Earth's atmosphere to search for near infrared signals of phosphine. I think it'll be tricky. We hope someday to send a probe to Venus, and NASA and ESA are already sending missions to Venus. But I think you'd want to go in the atmosphere itself and search for phosphine directly. I do want to add that this phosphine measurement, it has inspired so much work on Venus. And some of that work involves looking at old data from a NASA mission from the late 1970s that sent a probe down through the atmosphere. And this probe had a mass spectrometer that sucked in gases, ionized the gas, and subjected the ions to a magnetic field. And how those particles move through the magnetic field, the instrument and scientists are able to assign a mass and charge to each parent ion. And they can work back and infer the likely presence of phosphine using that independent method.
So when you finished your PhD, I don't know how many exoplanets were detected at that time, but if I see your website now, it's around 4,200 plus. So do you think that we can do some statistical analysis and focus more into the formation of planets and their atmospheres? And what could be the next frontier into this field of research?
So all good questions. We can do statistics now. We have to be very careful because we're so busy finding planets that astronomers typically aren't careful about what we should have found but don't find. So we like to say that it's easy to find the numerator, how many planets do we know, but it's hard to find the denominator, how many stars have we searched in a uniform manner. Some people do that, but you have to think about not just biases in your detection technique, but also instrument biases towards certain planet types and a huge number of other factors. So we can do statistics, but we have to be very careful. What's the next frontier? You know what the next frontier is for us, really? It is the James Webb Space Telescope, which many people woke up very early. I don't know what time it was in India. It was 7 a.m. Eastern time. So that must have been, oh, that was probably a much more favorable time, sometime in the evening.
Yeah, sometime in the evening, yeah.
Okay, that was way better for you folks. I was on the West Coast and woke up at 4 a.m. to watch the launch. But the James Webb launch, you know, it did such a great job. Everything went as well as possible for its deployment, and it's traveled to 1 million miles away from Earth to orbit at the L2, Sun-Earth L2 point. Well, the Webb will be able to access exoplanet atmospheres like we've never have been able to before. And I think we're all really excited to see what's in these atmospheres. Can it help us understand what the planet is made of, or perhaps something about its evolution? And we're really excited to search for atmospheres on rocky worlds to see if they exist at all, and if there might be water vapor indicating liquid water needed for all life as we know it.
So what is the definition of life according to you? Because when we, being an astronomer, we take part in public outreach, there is a like common question that, are there aliens in this universe?
Yeah, right.
So do you think that
Yes.
aliens means like intelligent objects, like super intelligent, what that we see in the science fiction movies, or you will be happy if there is a single cell?
Yeah, I love that question because we all want to meet an alien. I mean, who wouldn't want to? But we're just hoping, honestly, for any sign at all. We're assuming actually it's going to be that simple single-celled bacteria. And sadly, it's sad, but if we do find some kind of sign of life, we're not going to be 100% sure. And not only that, we wouldn't know if it was made by an intelligent creature or if it was made by simple single-celled bacteria. Some people want to make energy arguments. They'll say, you know, if there's oxygen, that combined with a lot of other molecules can release a lot of energy, therefore complex life needs oxygen. So some people have arguments like that, but honestly, on the whole, we won't know if there's aliens walking around, little green humanoids, or if it's just some kind of slime like you'd find in your refrigerator.
Yeah, that would be cool. But do you think that based on our current state of technology, we will be able to find some signatures of intelligent life? Like there is an institute called SETI. So how challenging it is to find some signals if there are really aliens in the
Well, I just want to flip that around a bit. I think the question more is, how common is life out there? And is there life near enough to send us a signal, either to show one by the bacteria, you know, producing gases, or is it close enough to, and does life want to, if intelligent life is there, send us a message? Just in my inbox is some people arguing again and again about METI, messaging extraterrestrial intelligence. Like, do you want to send a message out to other planets, hoping there's intelligent life there?
Yes, of course.
Well, okay, that's the first answer. What if you think about that a little more and think, okay, do I really want to tell them I'm here? It's like, hi, come get me. So there's a debate on this. I'm with you, but
Okay.
The debate is that we shouldn't tell people we're here. Why encourage them to a possibly violent civilization to come here and harm us? I'm just saying that's the debate. So we don't know what the aliens are thinking. If they're thinking that way too, and nobody's messaging us, even if they have the ability to, then we won't find them at all.
But do you think that we are not pushing these ideas, like we are, let's say, interested to work on dark matter, dark energy, it's fine for me, or even string theory. We are not trying to secure funding for this kind of research because we kind of think that this is impossible, or this is like a science fiction stories.
I see. Well, I think we just have to, unfortunately, be a bit patient, because we're still making progress. We know exoplanets exist. We know rocky exoplanets that might be the right temperature to host life exists. With the Webb telescope, we hope to be able to say that there are potentially habitable planets, those with water. We can infer water at the surface. So maybe as we move forward, perhaps if we find signs of life, even if we're not sure about it, it might motivate, other parts of the community to accelerate these searches. But there is a lot of work going on. I mean, there's SETI got an infusion of $100 million from a private foundation, Breakthrough Initiatives. There's now work going on to search for technosignatures, like pollutants in the atmosphere, like chlorofluorocarbons. So there is something happening, but there might be a future where there's more.
And how do you see when the richest person in the world, like Elon Musk, they show their interests in planetary science and talk about making the human species a multiplanetary living? So do you think that it's a ray of hope or silver line?
Anything is possible. But I think we have a long way to go. We have to make sure we can imagine going to another world. It's never going to be identical. And we're so fragile as humans. So I think if we have a way to genetically modify ourselves to tolerate whatever conditions are somewhere else, I think we'll have a better shot at surviving on another world. But I watch all the movies too. I watch the movies, Arrival. There's the movie Passenger. Have you seen that movie?
Oh, I did.
The big ship where the people are hibernating.
Oh, okay.
There's all kinds of ideas. People dream about a time when we might send raw biological material and DNA instructions that can be, tapered to like the conditions there. So I think there's a lot of possibilities, but it's still a ways off.
Yeah, the last movie I have seen is Don't Look Up. So yeah, so that's why I asked, be aware and do we have resources if there are some potential threats from the other part of the universe, or we are not aware that much about this fact that there can be not only intelligent life, but they can be threat to us also. Okay.
Right. I think anything's possible, but things are just so far away and it's so energetically costly to get anywhere. I don't think we're really ready to take it seriously.
Okay, thank you. So what is Sigar equation? Can we verify this equation in like not near future, but far future, let's say after 100 years?
Well, the Sigar equation, it is a takeoff on the Drake equation. And the Drake equation set out to write out all the terms to help illustrate what the search for signs of intelligent life by way of directed radio signals from that extraterrestrial life. And so the Sigar equation tries to similarly illustrate the terms involved for finding signs of life by way of gases in an atmosphere that might indicate the presence of some kind of life, most likely bacterial type life. And so like the Drake equation, the first few terms are something we can measure. But the last few terms, 2 terms or so, we can't measure, we don't think we can measure them. And so the whole equation is just there to kind of illustrate what's involved. So for example, we would start out with the number of stars available to us for a given survey. And then we'd ask, what fraction of those stars are quiet enough or observable actually to be, to have planets found around them. And then we'd further ask, what fraction of those stars have planets in the habitable zone? Like all those things we can quantify. And then we get to eventually a couple of more terms, what fraction of those planets have life on them? That's when we're not expecting to answer, maybe someday. And then the last term is out of those planets with life, what fraction generate a gas that can accumulate in the atmosphere and is also spectroscopically active? So the terms are there just for you to see, like breaking down, for lack of a better word, probability of us discovering signs of life with any specific quantifiable like survey of a set of stars with a specific technique.
Now let me ask one philosophical question, that do you think, are we special? I'm asking because from the cosmological point of view, there are 100 billion galaxies. Then if they have stars around 100 million or so, then even if I assume that 0.001% stars host planets, So there will be a probably 10 to the power 16, 17 planets. And let's say if I talk about the society, sociological aspect, if they host among them, let's say 0.001 or something percent, they have a religion. So how it could be. So just I'm trying to imagine, like, based on the model of the universe that we know from the standard model of cosmology, what if I build a society that is span across the universe? So do you think that are we special in that sense?
Well, no, I think the way you've described it, it seems that there has to be life somewhere out there with the hundreds of billions of stars and the hundreds of billions of galaxies. It's amazing. I think, though, that the question that I ask myself on a daily basis, it's not about all those hundreds of billions times hundreds of billions possibilities. It's about our local neighborhood. It's about the stars just around us that, at least for you and I in our lifetimes, we can access and study. And that hopefully our descendants can sometime travel to. But I don't see our descendants traveling to another galaxy, okay?
Yeah,
maybe to the very nearest stars. And so really it's just what is all around us rather than what is out there.
What are the challenges to detect basically, or to understand what is around us? Because as I said, that we can understand that how was the universe when it was, let's say, during the inflation 10 to the power minus 32 second, we can detect some gravitational wave and we can try to understand. So what are the challenges?
I mean, the challenges are simply that planets are very small, very low mass, and very dim compared to their host star. If we didn't have the star involved, it would be much, much easier. I always like to say, a planet like Earth at like a few to 10 light years away or tens of light years away, it's not fainter than the faintest galaxies ever observed by the Hubble Space Telescope. The problem is it's right next to a big, bright, massive star. That's our main challenge, is how we separate the starlight, how we can find the planet and study its atmosphere with or, by removing or not removing the starlight. So that's our main challenge. It's sort of a contrast.
But is it mandatory that we will always find signatures of life on a planet, or it can be on a comet or asteroid, or I don't know, maybe even in the void?
I think there are going to be arguments against the comet and asteroid. When we think about life and it has to sustain itself, and you ask, are there enough nutrients? Is there a possibility to cycle nutrients back in the planet to come back out? I think you'd find limitations on those comets and asteroids. But I wouldn't not look for it.
What can happen in next 10 years? You talked about JWST, but what do you think that how our understandings can be improved in next 10 years or so?
Of exoplanets or
of exoplanets?
Sure. I mean, I'll just pick two specific topics for you. One of them is these so-called mini Neptunes, the very common planets that are in between the size of Earth and Neptune, the ones we don't know what they're made of or how they formed. If we can see their atmospheres and see if they're all different or they're all the same, we can figure out what they are. We like to believe some of them could be water worlds, planets with 50% by mass water, like scaled up versions of Jupiter's icy moons. But they might not be that. They might just be like rocks with a hydrogen envelope, or they might be rocks with a hydrogen helium envelope. So I think we could learn something about those planets and how they formed and evolved. The second example I'd like to give you is about rocky planets. We have about 4 stars or so. They're small red dwarf stars. They give off a lot of flares. They're active. And there's planets in their so-called habitable zone, the right distance to be the right temperature for life, as heated by the star. But people are wondering whether those planets have atmospheres at all. Because small M dwarf stars, they had a very bad, call it teenage phase, a long, bad teenage phase, where they were giving off a lot of energy. So a planet in today's habitable zone, for tens to hundreds of millions of years, it was too hot to be a habitable zone. So I think just seeing those planets, whether or not they have atmospheres, and then if they do have atmospheres, follow-up studies to look for water vapor and biosignature gases will really be amazing. So those are just 2 concrete examples, and there's many more of what the Webb telescope can do for us.
Do you think that there can be alternative ways to detect the exoplanets? For example, I know one technique is called microlensing. So do you think that there can be other ways to have better detection?
Well, they're all each way is complementary. So every method like has its strengths and weaknesses. Microlensing will be big because our new space telescope called the Nancy Grace Roman Space Telescope, to launch later this decade, will include a microlensing survey. And it will help fill in our planetary census, especially for planets orbiting between 1 and 4 astronomical units from their host star. But those microlensing events, they're gone. Like once they happen, we can't, observe them again. So every method has its pros and cons.
I mean, reading the book, The Smallest Light in the Universe, I actually gifted some of my women colleagues on their birthdays. So I just want
thank you.
I just want to know that being a mother and having your personal life, how do you manage your research? Do you think that sometime managing your personal life, you have to sacrifice in your research life to some extent?
Well, there's always sacrifices all around, but what's very important is to have a supportive family, whether it's your parents, for women, your husband, if you're going to have a husband, and your friends as well. Like you need people to support you, just morally as well as like materially, really. And it could be family friends. I had several young women who started out as babysitters. Some of them lived in my house in exchange for helping with the kids. So family doesn't just mean the people you were born to, but it's the people that you grow around you in your community. Then the other thing, and I'm kind of giving this as like an advice session, is, when your kids are in school, you need to work. Like no fooling around on the internet, letting your mind wander, going out for lunch. I mean, you really have to focus, because then I don't, that's time when they're not expecting me to be around, or they don't don't necessarily need me, for lack of a better word. So it's really important to think strategically, almost like it's your own science problem. How are you going to optimize all the things going on? And so if I have to travel for work, I would invite family to visit, or make sure I had these family friends who the kids adored. I mean, the last thing you want, I've heard some horror stories of one of the people I know who's a lawyer. For a while, she had an au pair, a young woman living with her, and she paid to help with the kids. And the kids would cry whenever she came. You don't want that. So it takes effort to find the right people who can grow into being your family friends, or people to help take care of your kids. And it's really important to make sure when the kids are busy at school or whatever else they're doing, that you are really squeezing out what you can for that time.
In India, just a few weeks ago, one PhD student committed suicide, unfortunately. So we don't talk about the mental health situation during the research life. So when you were a student, did you ever went through a period of depression, and how did you if that is the case, how did you overcome these phases?
I was definitely depressed while I was a PhD student, and I told my dad, and he actually had a patient who just said, everyone's depressed as a PhD student. I don't know if you can agree or disagree, but supposedly everybody's very depressed at some point. And my dad had a really good reaction. He just said, you can leave. Why don't you just leave? And I feel like we get so wrapped up in what we're doing that we don't see that there are any alternatives. And I understand there's, especially in some cultures, a big pressure to succeed in what you started. But we all have to really work hard for individually, for ourselves and for our friends and other people, that you need to give people permission to fail. And either you walk away and then restart, or you just find something different. When I was depressed, I was thinking of alternatives. My dad wanted me to go to medical school, of course, but I thought I might try to go to veterinary school because I loved animals. I still love animals. So I was working, to kind of think of what else would I do. And it's hard because we work in a little bubble, right? And then you lose perspective. That's the main problem. My son goes to a college, undergraduate, called Worcester Polytechnic Institute. It's a STEM school, like a gentler version of MIT. It's project-based. It's a great school. Fantastic. Very happy with it. Between July and December of 2021, and the population of the undergrads is about, I want to say maybe 5,000 or 6,000, 6 suicides. This is a school in America. It's not MIT. And it's just heartbreaking. So this mental problem, it's not just the person you were talking about doing their PhD. It's kind of a huge problem for people that are like, you're in your bubble thinking, I'm not doing well, I can't do well, but in fact, you're doing fantastic. Or alternatively, everybody's suffering. The pandemic isolated us. And so I think like the mental health is a huge thing we all need to work on together. But I personally found that having friends, if possible, outside of the PhD, having activities outside of the PhD, trying to have perspective. You are not a number. You're not your grade. And trying to maintain that. If it's not the right fit or it's not working out, you're allowed to leave. And it's very hard to swim upriver to work against the culture around you. But all of those things are so important and hard. Do you have any thoughts of your own on this that you're willing to share?
No, what I like to do, I like to read many different books, particularly, let's say, Japanese novel, or maybe, I don't know, some failure stories who become successful at later time, even politicians who struggle to implement, because I find that this is kind of somehow very similar, because when you become a politician, nobody likes to give you like importance that you can change the world. But day by day, when you show the perseverance and you try to stick to your idea and try to somehow fit into it. So I have read the life history of many politicians, and somehow I get inspiration from that.
Right. I just want to build on what you're saying, that having like a hobby or something that fully gets your mind off your work is very important to reset and recharge, whether it's those political books or inspiring stories or reading or watching movies or going hiking or spending time with non-scientists.
Yeah, your book starts, I like the introduction, which is a hiking story and the way you made new friends. And this is very inspiring, actually. I read that introduction, and then I watched your interview in Brian Keating show. So I'd like to ask last two questions that what will be your advice to the young astronomer who are maybe a school student or a college student who are passionate about the universe or even planets, even aliens? What will be your advice to them?
Well, my first advice is to learn computer programming if you don't already know it, because I think you'll agree, most of astronomy right now relies on programming. The second thing is I would definitely, like if you want to be an astronomer for a job, study physics and math and computer programming. And third, no matter what you're going to end up doing, whether it's a job in astronomy or if astronomy remains your hobby, try to figure out how to network. We're never taught that, but figure out how to meet people, how to, if you can, get an internship. If you're going the route of a hobby, join an amateur astronomy club. So those are my three pieces of advice.
Oh, thank you. This is wonderful. I wish that somebody could tell me this particular advice that, okay, learn how to do computer programming. And it was always boring to me. It's like, but when I came to research, I found that, oh my God, I should be good at it.
Yes, it's my story exactly.
Okay, so another thing is that many people want to be like you, like a successful women scientist or a professor at MIT. You have many students who have become successful in their life. I personally know some of them. And also you have wrote, if I look only your publications, many nature papers and all those glamorous aspect of a, that is a part of a renowned scientist. So do you think that you have a life behind all these accolades, and how is your day-to-day life based on, like, how do you focus on your research and personal life or maybe other hobbies? And the next question I want to just ask that, what is your next goal? Do you aim to win a Nobel Prize one day?
All right, so there's a lot in there, but I'll just say I love working so much. I do have a life outside of work. My children are now almost grown up. One of them is about to turn 19, one is 17. And they have their own life now. And so teenagers, they don't want to spend as much time with their parents. But I do try to focus on them. It's like intensive, blocks of, okay, so let me say that again. So my children are almost grown up, which frees up my time quite a lot because I'm not their priority anymore. So I do have more time to work. I do have a wonderful husband, and I have a very cute dog. His name's Leo. He's a fluffy white golden doodle, and he's so funny and cute. And the great thing about the dog is every day is a fantastic day. Every new cookie is like the best thing ever. Every dinner is amazing, even though he eats the same dinner every day. Every walk outside is just like, wow, I just can't believe. So it really is so cheery because their attitude is every day, everything is exciting. And so it's great having my dog. So I do spend a lot of time with my husband and dog. I try to spend time with my children when they want to spend time with me, but I do work a lot. And my two main goals are sending a series of private missions to Venus. We have our first one in the works right now. It's probably a separate conversation that has a target launch date of May 2023. And we have a few others that we're working on as well to search for habitability in the clouds and signs of life on Venus. And then my dream, which will never diminish, is to find the true Earth twin. We'd like to block out the starlight with a sophisticated space telescope above the blurring effects of Earth's atmosphere and find that pale blue dot. So those are my two goals overall. So out of everything I've learned, I'm now in a phase of wanting to give back to the world. And I am starting a business, believe it or not, how to teach people, women especially, confidence and also strategy. But this confidence is key because typically for the same group of men and women, at the same confidence level, the women will drop out and the men will not actually. So to succeed, it's not the only thing, but a key thing that's missing is us building up our self-confidence, especially in cultures where women are not valued. Because you get this negative inner voice and it's very negative. And despite you could be a fantastic physicist, you could be a great programmer, but you'll never tell yourself that. So I'd like people to feel free to reach out to me. And I have I have a Gmail they could reach out to me on, which I can send you, keys2confidence@gmail.com. Because I have some pilot programs going that people would be welcome to join if they truly want to invest in their own confidence.
Wow, that's a great initiative. Organize basically the same thing to encourage women from rural areas to pursue career in science. I mean, it may not be science, it can be technology. But the problem is in rural areas or village, it is like the career path has been decided early enough. For example, you will get married at 26, you will have a kid around, let's say, 28, and that is the peak time for doing research. If
right. Well, I think we should definitely talk another time. I'd love to talk more offline because some things are very hard. Like there's the believing in yourself, but then there's all the practical things around you that are very hard to do. So, I'd like to see a future where we can help women build confidence, but then we also have a separate way to help them financially so they can still get all of this done. Like if the woman is to be married and have a child, then we need her to marry someone who supports her having a career. We need to support her financially so someone else can do the housework and she can spend time with her kids without having to do housework too. So I do think there's a way around it, but it's very hard.
I think we can plan another session where mainly women can ask you questions.
I think so. I think it would be very helpful for me too. And
we can organize
if the women reach out, then I can try to give them a hand.
Yeah, thank you. Thank you very much for giving me your time. I know that you are very busy and it is very nice talking to you, and at least I learned many things. So
I enjoyed the interview very much and thank you so much.
Thank you very much. And